they've done it again. After the success of the Model 1 Curta Calculator, first launched in 1949, this marvellous device has been updated to the new Model 2 with expanded calculating ability up to 11 digits. A delight to engineers, scientists, pilots and rally car drivers. Everyone loves their Curta. I've wanted to see one of these for many years. This is an original 1954 Curta Calculator. Unfortunately, it's broken. The internal mechanism is all jammed up. I can't move the main rotating handle on the top, simply doesn't want to budge. And I don't want to force it because the last thing I want to do is cause any more problems. Some of the input sliders on the side do still work, but a number of them are also jammed. So I'm going to have to fix this. And the way this came about was I was contacted by Ed from Historic Tech in the UK, and he said he had a damaged Curta, and he asked if I would be able to fix this for him. Of course, I immediately said yes. I found out about them many years ago from watching YouTube, and I was intrigued not just by the device itself. I was impressed by seeing just how prized these are by people who own them, such as Techmoan.
The item I'm going to show you today is one of the most precious things in my collection. A lot of people will know what this is already.
And Adam Savage.
It's one of my favorite objects in the world, a Curta computer. There are over 600 separate parts inside this.
And now that I get to see one, I can start to appreciate why. It feels so good to hold in the hand, and I can't wait to do some calculations. But before I can do that, I'm going to have to fix it. On the bottom there are two obvious screws, and removing them allows the bottom casing to easily slide off. Giving us our first glimpse of the amazing engineering inside. It seems to be made mostly of steel, but it looks like there's also some brass and maybe even some aluminium. During this process, I'm sticking to the rule of doing no harm. I'd rather not be able to fix this than do something that causes more problems. I mean, I usually try to follow this sort of rule with my own stuff, but it's never been more important than with this. The insides look nice and clean. The mechanism is already looking amazing, and I'm not even into the main section yet. The Curta is the invention of Kurt Hertzstark. He started drawing up plans for this design before World War II, which he then had to put on hold when he was imprisoned during the war for being of a particular ethnicity. Despite all this, he didn't give up. In fact, designing this while in prison helped keep him alive. When he was finally liberated from prison by the Allies, he then went on to start a company which then manufactured these for the next 20 years. I'm pleased to see that the serial number on the case matches the serial number on the internal mechanism. This looks like a complete original unit. But to fix this, I'm going to have to disassemble the top section. This is where things start to get a little bit tricky. The next step is to remove the top handle, which involves removing a precariously placed pin. And to do this, I'm going to have to use a radical dislocation method. In other words, I'm going to have to bang it out with a hammer in order to push the pin out, until I was able to dislodge the pin enough to get some pliers onto it. It still didn't want to move, but eventually I got it to pop out. The handle then comes off relatively easily, showing the next challenge. There's a spring-loaded locking ring that has to be removed next. This usually requires a special tool to open the locking ring and lift it out, which I don't have. But with a bit of improvisation, I found a small blunt pair of scissors is able to hold the spring open just enough to lift it out. I can now see the first clue as to what may have happened to this calculator. The shaft on the top appears bent, and this is a thick steel shaft and not easy to bend. This must have had quite some impact to cause this. Undeterred, the next step is more radical dislocation. According to the disassembly instructions, the top shaft has to be hammered until the brass ring around the shaft is removed. and reveal the insides. The top indicator dial also has its own set of complex gears to drive the output numbers. I'm pleased to see the top gears are all moving freely, as is the clearing ring that resets the top dial to all zeros. But I've spotted something else that doesn't look correct in this Curta. This pin in the top is called the carriage lock pin, and it appears to be bent very badly. This is a very solid piece of steel and another indication of a severe impact. With the top now removed, there are 3 more screws that have been revealed, and these are holding the third and final piece of the casing. This final piece slides off fairly easily, and there it is. The internals are revealed. Somehow this fantastic set of gears and levers is able to do addition and subtraction and multiplication and division on numbers up to 11 digits long, including floating point decimals, and there's even a procedure to find square roots using this thing. I'm slowly going through and very carefully checking each part in turn. I'm noticing that almost everything seems stuck, but carefully working each part is beginning to bring some movement back. I'm really pleased to see that with every small movement, I'm slowly bringing life back to this mechanism. I'm going to speculate that this was maybe dropped a really long time ago and then put away in storage and just left. I'm going to try turning the main shaft now, and even though it's still bent, it does seem to turn, and it even sounds good. It's time to do the first test, and for this I'm just going to do a partial reassembly. If I enter some numbers into the sliders on the side and turn the handle once, we can see those numbers are added to the output register on the top. I can also do subtraction by lifting the shaft into the negative position. Each rotation then subtracts the numbers on the side from the total number on the top dial. The way this subtraction works is called a nines complement addition, which is a way of using the addition of complementary numbers to do a subtraction. But during this testing, I found there is a problem here. This second register normally shows how many turns of the handle you've done. It's also used in multiplication to let you know you're getting the right result. And it's particularly important for division because this is where the answer is shown. Looking very closely inside, I can see that the gear for this section is indeed sitting higher than its neighbours. If I just very gently move it with a screwdriver, I'm finding that it was indeed stuck. Looking again at the mechanism, I can see that each gear has a carry lever. This is the part that actually moves the gear up and down when it's time to carry the 10. And the carry lever on this first gear looks like it's bent and unable to move this gear. So I'm going to very carefully remove the entire carry lever assembly. I have to be really careful because there's a number of very small parts here, including a tiny rectangular spring. And with the carry lever out, I'm just going to start bending it. It's not too hard, and I did feel it bend a little bit. Let's put it back and see how that went. It's not quite bent far enough, but it's pretty close, and the lever does seem to be moving the gear again. It's time for a proper test, and I'm going to do an almost complete reassembly. I'm now going to do a final test by doing a division. I'm going to divide 1,316,154 by 31,337. First, input 1316154 into the side and enter that into the top dial. I now have to use this lever on the side to reverse the counts. I also have to remove that initial 1 from the first turn and bring it back to 0. I now need to change the dial on the side to the second number that I want to divide by, in this case 31337. We should now be set up to do a division. I have to lift the shaft handle into the subtraction position and begin rotating. If I don't know how many digits the final result is, for example, I think it might be 4 digits long, Then I set the digit counter to 4 digits, but when I rotate the handle, I'll get 9s across the output register. That means that digit is a 0. I have to reverse this by switching the shaft back to addition and reversing that initial turn. Since I already know the result is 2 digits long, I'm switching to the second digit position, putting the shaft handle into the subtraction again, and begin rotating. Once I get to the 5th turn, I again see the 9s on the output dial, so I push the shaft back down to addition and reverse that last turn. Then switch the dial to digit 1 and start turning again. Get to the 3rd turn and reverse that. This will then give the result of the division on the second output register. $1,316,154 divided by 31,337 equals 42. I finally have the answer that I've been looking for. Thank you for joining me on this journey inside the Curta Calculator. I'm really pleased I was able to get it calculating again. I still need to get some proper oil to finish the job. There are certain parts in here that need tiny amounts of the correct oil. But for now, thank you for watching. I hope you enjoyed this experience with this amazing little machine. I'll be getting back to some slightly more modern tech in future videos, so I hope you stick around for that, and I'll see you then.